Here's our lesson over prime factorization. So the first thing that you need to ask yourself is, what is a prime number? A prime number is a number that has factors of only one and itself. So that means a composite number has more factors than just one in itself. So it would have more than just one and whatever other number. So it could have 3 factors, it could have 4 factors, 5, 6, or 7, but it's going to have more than just the 1 and whatever number you're trying to find factors for. So some prime numbers, the very first ones are 2, 3, 5, 7, 11, 13, 17. They keep going on and on. Sometimes it's helpful to make a 100 chart and highlight the prime numbers in there. We're going to be doing a lot with prime factorization in the next few lessons, and then you'll see throughout the year that prime factorization will come up again and again. You will use prime factorization in the upper levels of math, such as pre-algebra, algebra, geometry, algebra 2, when you get into calculus. So it's something that you really want to make sure that you pay attention to and master. So make sure you're focusing today and throughout the rest of this chapter, asking questions if you need to. So you guys know how to write composite numbers. We're going to write composite numbers as a product of their prime factors. So you guys have done this using 2 different methods, possibly in the past. If not, we'll learn them and review them today. So the first one that we're going to look at is the prime factorization chart. Okay, so it looks like this. If you haven't used it before, that's okay. We'll learn how to use it. So we're going to use this chart here, and we're going to find the prime factors of 78. Okay, so we put 78 inside this little rectangular box, and then we're going to think of these prime numbers up here. I always say start with the lowest, because when you write your composite number as a product of its prime factors, you have to put the prime numbers in order. So you might as well start with 2 right here so that your numbers will start being in order right here. You may use a calculator. So if your teacher didn't tell you to get a calculator out, you can get a calculator. You'll see mine here. You won't necessarily be able to see the numbers, but they're there. So I'm going to take 78 and I'm going to divide it by, I know I can divide by 2 because it's even. Those are my divisibility rules. So I'm going to take the first prime number and divide it by 2. And I get 39, if you can see my calculator. So I put the 2 over here, which is the prime number, and 78 divided by 2 is 39. So it's similar to like a long division chart, but it's just a little bit flip-flop from it. Okay. Now I look at 39. It's not an even number, so I know I can't divide by 2, so I can't use that prime number again. So I'm going to go on to 3 and see if I can take 39 divided by 3. Some of you may know what that is already. If you don't, put 39 divided by 3 in your calculator. If you got a decimal, you would know that you couldn't use 3 as a prime factor of 39. But since it does not come out as a decimal, 39 does have 3 as a prime factor. So we're going to put the 3 out here, the prime factor, and put the 13. So 39 divided by 3 is 13. Okay. Now I'm going to see if I can take 13 divided by anything else. When I look at my short list of some of the prime factors up here, I can see that 13 is a prime factor. So when I see that 13 is a prime factor, I know that I can stop. So I'm just going to draw a line to tell myself to stop. Okay. Then it says to write a composite number as a product of its prime factors again. At the very beginning, remember I said that you had to write the prime factors in order. Okay. So I have 2 as a prime factor of 78, 3 is a prime factor of 78, and 13 is a prime factor of 78. So if I write those in number order, 2 is less than 3, 3 is less than 13. So I'm going to write 78 is equal to 2 times 3 times 13. And that would be my answer, and I would box it or highlight it since I have some other work there, or both is fine as well. And that is finding the composite number, which I have, and using the product of its prime factors, okay? To check to see if this works, I'm going to take 2 times 3 times 13, and what do you think you should get? The answer is you should get 78. And if I do, then I did my prime factorization chart correctly. I can put a check mark beside here that I checked this answer on my calculator, and I can move on to the next problem. So our next problem that we're going to do is, instead of doing the prime factorization chart, we're going to do method 2 with the same problem. So method 2 is using a tree diagram, but still using prime factors. Okay, so we're going to isolate those prime factors. Move this down so you can see the list again. So the first prime factor I'm going to use again is 2. So 78 divided by 2 was 39. So this was my prime factor. I'm just going to circle it so I can see it. I can't divide that anymore without just having 1 and 2, which would be the same. So I'm going to take the 39 and I'm going to make a tree off of that. It's not even, so I can't divide by 2, so I'm going to try 3. And I know from my other chart that 39 can divide by 3, and I get 13. So I'm going to circle my prime number again. And then remember, we looked at the list and saw 13 was a prime number in my list, so I can't divide that anymore. So I have a stopping point. I can't split off any more of those prime numbers into other prime numbers. So I know that 78, which is my composite number, because it can be split into other numbers than just other factors than just one in itself. And then if, as a product of its prime factors, would be 2 times 3 times 13. And then again, I would want to check it on my calculator and say 2 times 3 times 13 is 78, which we checked on the other problem. So I can put a check mark by that I have checked my answer. So we're going to practice this just in case you didn't know how to do it before. You can use those as an example. So we're going to do method 1 first. So the first thing you should be asking yourself is 48. What prime number should I divide it by? Okay, you should know that you can divide 48 by 2. You can also divide it by 3. However, 2 would be the first prime number I can divide it by, so I'm going to do that first since I have to list my product in order from least to greatest. So 48 divided by 2 is 24. And then I look at 24. Can I divide 24 by 2? And the answer is yes, because it's even. That's a divisibility rule. So you should be starting to see that your divisibility rules will greatly help you in 6th grade. So 24 divided by 2 is 12. Should be math facts that you know. 12 is still even. I can divide it by 2. 12 divided by 2 is 6. 6 is still even, so 6 divided by 2 is 3. And there, that pops up with my prime number of 3 that I could have divided the 48 by. So I stop because that's a prime number. And then I have 2 times 2 times 2 times 2 times 3. So I'm going to check this on my calculator. If it helps you to write it out first, you can write out the 2 times 2 times 2 times 2 times 3. Now, some of you that know exponents, I could write this as 48 is equal to, there's 4 different 2's, so it wouldn't be 8, but it would be 2 to the 4th power times 3. Either one is okay as long as you know how to solve that. So it would be 2 times 2 times 2 times 2 times 3. And I get 48. So it does check. 48 as a product of its prime factors is 2 times 2 times 2 times 2 times 3. Okay, and then using method 2, I can use the tree diagram and do the same thing. 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3, which also is a prime number, so I would stop there. And again, you can see the 4 2s and the 1 3. So 48 as a product of its prime factors, and we know product means multiply, so 2 times 2 times 2 times 2 times 3. Ran out of a little bit of room, but that's okay. And I checked it over on the other problem, so I know that that is correct. So you're going to be doing those types of problems on your independent practice today. So if it says write a composite number as a product of its prime factors, you can look back at these examples to remember how to do that.